In this video, we're going to look at color coding, which is a technique for looking at the voltage in a circuit. Specifically, color code circuits, and then use that to help us apply the loop and junction rules. Really, this is all about understanding the voltage gain and drop in a circuit, voltage gains at batteries and drops at other circuit elements, helping us think about current direction and the difference between series and parallel arrangements of circuits. Will also help us identify what's known as a short circuit, which is a place where kind of weird things happen. The basic rules of color coding are these. Colors represent energy levels. We use red to represent the highest energy, which we use as the positive terminal of the battery. And blue is the lowest energy, which is the negative end of the battery. They go in sort of rainbow order, and we start with the two ends of the battery. Every circuit with a battery in it will have red and blue, and then we'll fill in the other colors as needed. Usually we go red and blue, and then we add yellow if we need a third color, and then we kind of fill in with orange and green if we need those as well. You can skip colors, but you always have to have red and blue. These show energy changes, right? If there are two different colors, then we have a voltage or an energy per charge across that section, and that will cause current to flow. We only change our color at batteries and resistors, circuit elements, not at junctions. The junctions are places where that potential stays the same until it hits a resistor or a battery. The color changes can also help us think about current. The conventional current flow flows down the rainbow from red to blue, red, orange, yellow, green, blue, and then the battery is the only place where it goes the opposite direction. This also allows us to identify places where if a resistor has the same color on both sides, it does not have a potential difference. It does not have a voltage, and there will be no current flow. There might be a short circuit, or there might be something else going on. So we can color code these circuits. These are two fairly straightforward circuits. The one on the left is the most simple circuit you could have, a battery and a single resistive element, right? We have red from the positive terminal of the battery and blue from the negative terminal of the battery, meaning that we have, red to blue across the light bulb. The current will flow from red to blue clockwise around this circuit, and that will be a 6-volt battery, or 6 volts across the light bulb. Now, there's two ways to identify this. There's the loop rule, which is really what we're doing, that says as you go around the loop, plus 6 volts from the battery, minus 6 volts from the light bulb. Those are the gains and drops. But if you look at the color coding, it can tell you this as well. If red to blue in this circuit is 6 volts, because that's what the battery is, anytime you see red and blue, the voltage or potential difference from those 2 points is also 6 volts. If we go to this other circuit, which is a series circuit with 3 light bulbs in it, we have red from the battery, blue from the battery, and then we need to fill in. Now, we could use any of the 3 remaining colors, orange, yellow, or green. In this case, I've used orange and green because I need 2 of them. And what we see then is that we have 3 different voltages. We have 2 amps of current running clockwise around the circuit again. But if these bulbs are identical, and this is a little bit of a cheat, we'll talk more about this later, but if they're all identical, they should each have the same amount of voltage, 2 volts each. So the color pairs that we have here are red and orange is 2 volts, orange and green is 2 volts, green and blue is 2 volts. But that doesn't always have to be the case. As we'll learn with Ohm's law, if each of these bulbs have different resistances, then those voltages for each of them could also be different. We can color code a different kind of circuit. This is a parallel circuit. Red from the positive terminal of the battery. Notice that the red goes through the junction until it hits the light bulbs, and blue on the other side. We have current flow direction, and we know since these are both red, they both have 6 volts across them. And you probably saw some of this when you did the Introduction to Circuits lab, or will when you do the Introduction to Circuits lab. The color must change. If the color change must be the same, then the voltage must also be the same, right? If there's no other option other than going red to blue for each of those, then they each have to have the same voltage as the battery. And that's something special about a parallel circuit. These bulbs don't have to be identical. No bulbs do, but in this case, they still would have the 6 volts across them. They just would have different currents running through them. And that kind of wraps up our basics on color coding. We'll look at this a little bit more. I have another example of what happens when you charge and discharge a capacitor, but we haven't learned about capacitors yet, so we'll save that for later.